Hi, everybody. Today we're going to be taking some notes. Now, your notes are titled Chemical Batteries or Oxidation and Reduction. However, before we dive into those terms, we're actually going to talk about some more general terms and some more general categories. So, last class, what we looked at was review. So, we did some ion stuff, drew some ion pathways, and had some reminders about electron and electron movement. That's all going to tie in towards the bottom half of our notes. For the first half of our notes, we're going to be in the more general category of energy. Now, energy has a lot of different forms and a lot of different types. Some of those forms and types we are going to look at in depth, and some of those forms and types we're going to keep it pretty surface level. But we're going to start by making a list of some examples of each. Now, we're going to split this into two categories. So on the left, I'm going to put potential, which would be stored energy. And we are going to compare that to, so versus kinetic, which would be energy of motion. And I'm going to split that, and I might need to make that a little bit longer later. We're not going to get super technical with our definitions today. We're going to make a list of some examples, and then we're going to dive deeply into one of those examples. So, potential or stored energy. One of these examples we have already covered in this class. Our first unit was nuclear energy, which was energy that was stored in unstable nucleuses or nuclei. Radium had potential energy in its nucleus because its nucleus was unstable. Similarly, there is chemical energy, which instead of storing energy in the nucleus of an atom, is going to store energy in the bonds between atoms. So, to understand the difference here, it's really subtle. Nuclear is going to be looking at the nucleus of a individual atom. So, we've been drawing those Bohr models. I'm just going to draw a little one. That will be the energy stored in here. Chemical energy is going to be the energy stored between connected atoms. So now if we have two atoms, connected by a chemical bond, the energy in between those atoms would be chemical energy. And we'll talk a lot more about bonding and connecting atoms later. But that's just the subtle differences between the two. Then, some other examples that you might be familiar with, there is elastic potential energy, which would be if you have something stretched or coiled, so think like a rubber band. There is energy stored in that stretched out rubber band. And then there is gravitational potential energy, which is potential energy due to an object's relative position on Earth. So something up tall could fall down. That would have gravitational potential energy, like a rock on a hill. All of these are stored. Nothing is moving. Once things start moving, we're no longer potential energy. We are into the kinetic energy category. So something that might start moving is particles. That creates thermal energy, which is energy relating to the movement of particles producing heat. We will talk about this one more in depth later, and we'll do a demo as a class relating to this. So we will come back to thermal energy. We can also have moving parts, which would create mechanical energy. So think like moving gears. We could have energy moving on sound waves. That is vibrational energy. We could have energy moving on light waves, which is actually a combination of particle and wave movement. Or we could have electrical energy, which a lot of you are familiar with because you use light switches, but you may not actually know that electrical energy is the movement of electrons. So this is our list. What are we talking about this unit? Energy. Lots of different types of energy. We won't dive into all of them. Nuclear energy, we've already covered. Gravitational energy, you cover a lot more in ninth grade science. We are going to focus in on the forms of energy relating to chemistry. We'll come back to this chemical and bond energy in a different unit once you know some more about bonding. But for now, we're going to focus in on thermal energy. We'll do a demo relating to that. And we're going to zoom in on electrical energy, which is the movement of electrons. And your final task in this unit will be a lab relating to this. Now, back to our topic for today. Chemical batteries, oxidation and reduction. We're looking at the vocabulary and the introductory science that's going to let us understand this form of energy. So I'm going to my paper. Because we're done with the background and now we're going to dive into the specifics of oxidation and reduction or chemical batteries. And electrical energy. Now, first of all, lots of vocabulary here. So, first thing we've already talked about is electrical energy. What is electrical energy? It's the movement of electrons. We've been modeling that when we draw ions. You guys already know a little bit about that. However, I haven't talked about the other two terms in our header, which is oxidation and reduction. Oxidation and reduction, when we combine them together, we call them a redox reaction. A redox reaction is the type of reaction or the type of chemical process behind electrical energy. Specifically, oxidation The first half of this process is the loss of electrons, while reduction is its other half, the gaining of electrons. You combine these two, you get a movement of electrons. This movement of electrons creates electrical energy. Now, that's a lot of vocabulary soup in here. If we take a highlighter, and I'm going to use a yellow colored pencil so I don't smudge my marker, we've defined redox reaction, and we've defined a lot of other terms in that process. We've defined oxidation, and we've defined reduction. A mnemonic to help you remember this vocabulary soup is the phrasing oil rig. So I'm going to take another color to adapt to my memory trick over here. Now, oil rig is a trick to memorizing or remembering the difference between oxidation and reduction. Oil, OIL, means oxidation is loss, which is the loss of electrons, while rig means reduction is gain, which would be the gaining of electrons. Combine those to get a redox reaction. What is this? The chemical process behind electrical energy. This process is really powering the movement of electrons. Now, redox reactions are not explicit to electrical energy. There's actually a ton of redox reactions occurring in your body all the time. We are going to limit our focus to understanding batteries. To help with that understanding, we're going to turn all this vocabulary into a model of a simple chemical battery. And this model is going to be important because your final task in this unit is to make a battery and quantify the amount of energy produced by that battery. So, how are you going to do that? It's not going to look like the batteries from Walmart. There's not going to be a protective casing with a bunch of different pieces and parts on the inside. We're going to keep it simple. We are going to start by having two different metals, and these metals are going to be called electrodes. So metal number one, I'm going to call magnesium. Metal number two is going to be aluminum. These are just going to be metal strips. There were lots of different metals I could have picked, but all batteries have something in common. They have different metals combining that will eventually form this redox reaction. And those metals are going to be in a solution. So I'm going to draw them in a solution or a beaker. Use wiggly lines to represent that liquid. And then these metals are also going to be connected by a wire. Okay, so this is my bad. Let's explain a little bit more about what we draw. What we drew started with two metals. If you remember what I called these were identified as our electrodes. Your electrodes are going to be metals that are capable, willing, and wanting to move electrons. So if we go back to what we reviewed yesterday, and we focus in on magnesium. Magnesium is element 12 on the periodic table. It's in column number 2, which means we know it has 2 valence electrons. Now, 2 valence electrons is not a stable electron configuration. So what magnesium is going to tend and prefer to do is ditch those electrons, give them away, and form an ion, Mg plus 2. This process is the start of electrical energy because this ion formation released electrons for a redox, which is an oxidation and reduction reaction. So magnesium, the metal, is going to send 2 electrons running down the wire. And it's really going to happen many, many times. So that ion is going to form, and these electrons are going to be sent down the wire and travel to aluminum. So magnesium would be identified as the oxidation portion of this reaction because it lost the electrons, while aluminum has gained the electrons. So it would be the reduction portion of this reaction. Now, this flow of electrons can be quantified. If you wanted to just look at it qualitatively, what you could do is put a light bulb on this wire. When the electrons moved, the electrons would light up the light bulb. We will be attaching voltmeters to the wire, and we'll be able to quantify that electron movement. The more electrons you're moving, the more electrical energy you're going to make, the stronger your battery is going to be. Now, I also pointed out that these electrodes have to be sitting in something. We can't just have magnesium and aluminum on a counter. They have to be in an ionic solution because we're creating charged substances. So here we have Mg plus 2. We can't just build up a bunch of positive charges. A bunch of positive charges would repel each other. The battery would stop working. So we do need to use an ionic solution, which is going to be a solution with positive and negative ions. Those positive and negative ions can move around for charge balancing. Okay, so that's our notes for today. Brief overview of what you should have gotten out of this. You should have an understanding of what this unit is about. What are we looking at? Energy. Lots of different types of energies. However, we are going to focus in on 2. We're going to do a demonstration about thermal energy. You're going to do a lab about electrical energy. Now, thermal energy, a little bit easier to understand. So what did we do with the rest of our time today? We previewed electrical energy before you do your reading. What is electrical energy? Combination of oxidation and reduction reactions. This is called the redox reaction. What is that? Essentially, moving electrons. You move those electrons, that flow of electrons creates an electrical current. How can we set that up as something that we can do and measure? Well, we can make simple chemical batteries involving electrodes connected by a wire in an ionic solution.